All right, now let's take a look at this a slightly different way. Let's say, could I find A? Now, if I think about this triangle here, and I'm just going to kind of draw it in here so you guys can see what I mean here, what triangle I'm talking about. I'm just going to kind of dot line it here so you can kind of see the other line, the original line too. Okay, so that's the triangle I'm talking about. We can say that's a right triangle there. And we can say that this side is A here. Okay, we can say this side here is B, that length. Okay, and then another thing we can do is if we want to talk about this in terms of just their components. Now, would you guys agree that this side over here, if I looked at this magnitude, that would be the magnitude of U, and that would be the length of this side here? Hopefully you guys see that okay. All right, so then if I was going to think about this, I could say, and then I can call this a theta, couldn't I? Right, it could be any angle. So I could say the cosine of theta actually equals A over the magnitude of U. So then if I wanted to solve this for A, I could actually say A equals the magnitude of U cosine of theta. So that's kind of what's interesting here is if I know the angle and I know the magnitude of the vector, I can actually find A. And then also, very similarly, if I did the sine of theta here, that would equal B over magnitude of U. So then if I solve for B, I could say B equals magnitude of U sine of theta. Now again, these are kind of handy too. If I knew the angle and the magnitude and I didn't know A and B, I could actually find them. So this is kind of a nice little tool we can use to think about these vectors in a different way, given different information. So given a problem like this, find U given theta equals 30 degrees and magnitude of U is 50, we can simply plug it in and find U. Now remember, U is going to be of the form A comma B. So if we're going to find U, that's what we're looking for. So we're looking for A and B. Okay, so let's find that now. So I do know that A equals magnitude of U cosine theta, which equals 50. And then cosine of theta is not theta. I'm going to put in place of theta cosine of 30 degrees. So now when I work this out, that's going to equal 50. And what is the cosine of 30 degrees? Hopefully you guys are okay with saying square root of 3 over 2. And if not, get comfortable with that, guys. Okay, this last test is going to be full of this stuff. And then I can actually simplify this because 50 and 2. So it's actually going to be 25 square root 3 for the A component. Now for the B component, it's going to be the square root of, not the square root, excuse me. It's going to be 50. I'm just going to plug it in kind of right away. First one, I just kind of wanted to show you everything. And then I'm going to write sine of 30 degrees. And the sine of 30, remember opposite over adjacent, opposite to 30 is the 1. So this is going to be 50 times 1/2, which is just 25. So then our final answer here, I'm going to put it in a different color here, is actually going to equal 25 square root 3, comma, 25. So there's our answer. So just given different information, I could think of vectors in another way. So there's our answer.